Advanced Higher Chemists, this one is for you. Let's go over the mechanism for acid catalyzed hydration of an alkene. Acid catalyzed hydration is where we react an alkene and hydrate it with an acid as a catalyst to produce an alcohol. In simple terms, when we hydrate it, an OH goes on one side of where the double carbon-to-carbon bond was and an H goes on the other. Then using Markovnikov's rule, we can work out which the major and minor products are. But we're not going to talk about Markovnikov's rule in detail in this video, we're going to look at the mechanism. So here we have all our reactants. One thing to bear in mind is that a pi bond is electron dense, so it's technically a nucleophile. It's got a lot of negative electron density here, which means it's only going to attract something that is positive. So what happens in the first instance is the double bond breaks and picks up one of the hydrogen ions from the hydronium. This then breaks the double bond and ends up forming a carbocation. And at this stage, you will also have two molecules of water. One of these is the conjugate base that has resulted from your acid reacting, and the other molecule is the water molecule you were using for the hydration to start with. Remember, opposite charges attract, so now a lone pair of negative electrons will be attracted to this carbocation, so this water molecule will donate a lone pair here. You then end up forming this molecule where you've essentially got a water molecule attached to the carbon compound. This thing we've got here is obviously not very stable, so in comes our conjugate base to save the day. It takes one of its lone pairs to pick off one of these hydrogens to then stabilise this molecule. That then results in us forming the alcohol, which in this case was propan-2-ol, and our hydronium ion again. Because we end up with our hydronium or acid back at the end of the reaction, this is why it's acted as a catalyst, because it has remained unchanged at the end of the reaction. If we were forming propan-1-ol, we would have this carbocation intermediate forming instead, where the water molecule would donate a lone pair of electrons in there, forming this molecule here, which would then go on to form this here. Just to finish off, my top tip for learning synthesis mechanisms is to form a wee description of each stage of the mechanism that makes sense to you. So for example, the first stage of this, I might say to myself, the double bond breaks and picks up a hydrogen off the hydronium ion to form an extra water molecule. As long as that makes sense to me and allows me to then draw that as a mechanism, it doesn't really matter what the wording of the description is because it's going to be put into picture form anyway. But having some descriptive steps that make sense to you can really help you recall the mechanism when you need it in an exam, because rather than trying to imagine the picture that's maybe a bit abstract to you, you can just remember the set of instructions or descriptions you've given to yourself instead.